So we come to the sessions to define some problems on a Cauchy integral formula and generalizing the Cauchy integral formula. So using a formula is evaluated some problems. So generalize the Cauchy integral formula. If f of z is analytic inside and a simple closed curve C, if A is a point within C, then fn of nth derivative is equal to nth derivative of A equal to n factorial divided by 2 pi I integral of f of z divided by z minus A whole power n plus 1 dz. See, if f of z is analytic on a simple closed curve C, A is a point within C, then the nth derivative should be equal to n factorial divided by 2 pi I integral of C f of z divided by z minus A whole power n plus 1 dz. So by using a Cauchy formula, Cauchy integral formula, so f of z equal to 1 by 2 pi I integral of C f of z divided by z minus A dz. So the Cauchy, by applying a Leibniz rule for differentiating under integral sign, you are so derivative, first derivative of this equal to 1 by 2 pi I integral of C f of z dou by dou A of 1 by z minus A of dz. So you are applying a Leibniz rule for differentiation under integral sign. This is a formula for under integral signs. So first derivative should be equal to 1 by 2 pi integral of f of z. We are differentiating here. So we get minus 1 if we take this minus 1. So denominator derivative of numerator minus numerator derivative of denominator we get. So minus 1 times of 1 by z minus a whole square of derivative of a is minus 1. So we get, so I keep this form is 1 by 2 pi I integral of C f of z is, I take a minus of minus 1, we get 1 divided by, simply say 1 factorial. So in the similarly, we come to the first, we can write 1 factorial derivative of A is 1 factorial divided by 2 pi I f of z divided by z minus A whole square dz. We observe first derivative, we have obtained z minus A whole square. See here, we observe first derivative 1 factorial divided by 2 pi I integral of f of z divided by z minus A whole square dz. Again applying the Leibniz rule, we get second derivative is equal to 1 factorial divided by 2 pi I integral of f of z dou by dou A of z minus A whole power minus 2. You are easy for, if you take this numerator, we get z minus A minus 2 whole to the power of minus 2, z minus A whole to the power minus 2. Start integrating, start differentiation. We get 1 factorial by 2 pi I integral of f of z minus 2 z minus A whole power minus 3. Again derivative of A is minus 1 dz. Again that is, so we get minus 1 minus 2. Suddenly we get minus plus 1 into 2. Suddenly we can write 2 factorial. So 2 factorial divided by 2 pi I under integral sign, integral of C f of z divided by z minus A whole cube dz. So here second derivative, see observe in the second derivative 2 factorial divided by 2 pi I integral of C f of z divided by z minus A whole cube dz. So second derivative get z minus A whole cube dz. Continuing like this way, after the differentiating n times, so nth derivative f of A of 1 n, it should be equal to n factorial divided by 2 pi I integral of C f of z divided by z minus A whole power n plus 1 dz. See, this is the, by applying the Leibniz rule, Leibniz rule, we get that nth derivative should be equal to n factorial divided by 2 pi I integral of f of z divided by z minus A whole power n plus 1 dz. So fn of A, nth derivative of A, denote the nth derivative of f of z. So nth derivative of A, we note f of z at z equal to A. Now, so what's the method? The working procedure for evaluate the problems. See here, working procedure to evaluate the problems on Cauchy integral formula of the function of the form integral of f of z divided by z minus a dz, integral of f of z divided by z minus a whole power n plus 1 dz over a given a closed curve C. First find out whether the point z equal to a lies inside or outside the given curve C. So first check out at z equal to a lies inside or outside the given curve. If z equal to a lies inside C, then use the Cauchy integral formula for the integral of f of z divided by z minus a dz equal to 2 pi I f of a. When the z equal to a lies inside the circle, use the formula integral of f of z divided by z minus a dz equal to 2 pi I f of a. Integral of C, f of z divided by z minus a whole power n plus 1 dz equal to 2 pi I by n factorial nth derivative of a. So, if the point z equal to lies outside C, supposing that f of z equal to f of z divided by z minus a or f of z equal to f of z divided by z minus a whole power n plus 1 is analytic inside on a given curve C, we conclude that integral of f of z dz equal to 0. Then, so is analytic inside. So this is analytic inside and given curve C, we conclude that the Cauchy integral formula hold. Cauchy integral formula hold means integral of f of z dz equal to 0 by Cauchy theorem. Then inside the circle. So this we take simple problems. We take a problem. Evaluate integral of e power 3z divided by z square dz over the curve C mod z equal to 1. So these solutions, the given integral can be written as integral of e power 3z divided by z minus 0 whole square dz. Here a equal to 0. So that's a. So if I take a formula, integral of f of z divided by z minus a whole power n plus 1 dz is equal to 2 pi I by n factorial nth derivative of a. So I take a formula. So integral of f of z divided by z minus a whole power n plus 1 dz is equal to 2 pi I by n factorial nth derivative of a. The point a is 0 lies within a circle. Mod z equal to 1. So a equal to 0. So this is the given circle at z equal to mod z equal to 1. So the radius is 1 and the center is 0. That is, take f of z equal to e power 3z. Then a equal to 0, n equal to 1, first derivative. A equal to 0, n equal to 1. The above formula become f of z divided by z minus a whole power n become integral of e power 3z divided by z square dz. Given problem. So 2 pi I divided by 1 factorial. N is 1 factorial derivative of f of 0 because a is 0. So again, as substituting f of 0 should be equal to e power 3 into 0. Suddenly 1. E power 0 is 1. So e power as substituting. Again, derivative f of z equal to 3 e power 3z. So derivative f of 0 should be equal to 3 into e power 3. Suddenly it become 3. 3 into e power 0. Suddenly it become 3. So I am substituting. So therefore integral of e to the power of 3z divided by z square dz is 2 pi I. Derivative of first derivative at a equals 0 means we get 3. And 1 factorial is 1. So suddenly 6 pi I. So we come to the one more problems. So evaluate integral of c z square plus z plus 1 divided by z minus 2 whole cube dz over c mod z equal to 3 or c mod z is equal to 3. So again we will come to the point here z equal to 2 here and a is 2. So suddenly the point a lies inside the circle. So at z equal to 2 lies inside the circle mod z equal to 3. We generalize the Cauchy integral formula. Integral of integral of f of z divided by z minus a whole power n plus 1 dz is equal to 2 pi I by n factorial nth derivative of a. So 2 pi I n factorial nth derivative of a. So taking is given function, take a function f of z is equal to z square plus z plus 1. So first derivative, what is the first derivative of here? 2z plus 1, 2z plus. Second derivative simply 2. So second derivative is 2. At second derivative z equal to 2 is also 2. Is also 2. Means first derivative 2z plus 1, second derivative 2. Again, if I replace z by 2 is same as 2. So here a is 2, a equal to. The second derivative n equal to 2. So n equal to. But again, I come to the problem. Integral of z square plus z plus 1 divided by z minus 2 whole cube dz should be equal to formula 2 pi I n factorial is 2 factorial. Is 2 factorial is 2. Nth derivative is 2 second derivative. Second derivative at a equal to 2 become 2. So again 2 to get cancelled. You get 2 pi I. 2 pi I. So if you come to one more problem in form of mod z equal to 3. So evaluate integral of e power 2z divided by z plus 1 whole square into z minus 2 dz, where c mod z equal c such that mod z equal to 3. The first result is a proper fraction in the form of proper fraction. So this is a partial fraction, is certainly a proper fraction. 1 divided by z plus 1 whole square into z minus 2. So again we write this convert in the proper fractions. A by z plus 1 plus b by z plus 1 whole square plus c by z minus 2. Here ABC is unknown to find by using proper fractions. First we take denominator, so z plus 1 whole square z minus 2 of a times of that term. So a times of z minus 2 into z plus 1 plus b times of z minus 2 plus c times of z plus 1 whole square. By using a suitable substitution, put z equal to minus 1, put z equal to minus 1, we get z equal to minus 1, we get b and c. Z equal to 2, put z equal to 2, we get ab. Similarly, we get substituting by where in this way we get values of a is equal to minus 1 by 9. The values of b is equal to minus 1 by 3. The values of c equal to 1 by 9. So I am substituting here. By substituting where the values of a equal to minus 1 by 9, the values of b equal to minus 1 by 3, the values of c equal to 1 by 9. So substituting. So that is for integral of e power 2z divided by z plus 1 whole square z minus 2 dz is same as integral of a divided by z plus 1 dz plus integral of b divided by z plus 1 whole square dz plus integral of c divided by z minus 2 dz. So as substituting the values of a, b, c, we get integral of minus 1 by 9 integral of 1 by z plus 1 dz minus 1 by 3 integral of 1 by z plus 1 whole square dz plus 1 by 9 integral of 1 by z minus 2 dz. So we get, so we come to the f of z is, so minus 1 by 9 integral of e power 2z divided by z plus 1 dz minus 1 by 3 integral of e power 2z divided by z plus 1 whole square dz plus 1 by 9 integral of e power 2z divided by z minus 2 dz. See, you are observed here a is 1, 1, 2. So a is minus 1, 1, 2. So all the point lies within the unit circle. So because mod z equal to 3, the lies within a circle. That is, the point z equal to a equal to minus 1, the point z equal to a equal to 2. So instead of z plus 1, we can write minus of minus 1. Here also minus of minus 1. So here is a is 2, a is minus 1. So suddenly the point z equal to a equal to minus 1, z equal to a is 2 lies inside the circle mod z equal to 3. So first and the last integral of the right hand side, consider Cauchy integral formula for integral of f of z divided by z minus a dz is 2 pi I f of a. So in the second integral, Gauss integral formula in the form integral of f of z divided by z minus a n plus 1 dz is 2 pi I n factorial nth derivative of a. So I come to the problem. So function f of z is e power 2z. So start the derivative of f of z equal to 2 e power 2z. E power 2z. Again replacing z is minus 1. Derivative of f of minus 1 should be equal to 2 e power minus 2. So simply we can write 2 divided by e square. So again we come to the problem. Now integral of e power 2z divided by z plus 1 dz is integral of 2z divided by z of z minus of minus 1 dz. So is a is minus 1, that is 2 pi I f of minus 1. So simply we get 2 pi I. So f of minus 1 is e 2 by e square, that is, so sorry, f of minus 1 is, if we replace f of minus 1 is, that is we get, so e to the power of minus 2, that is e to the power of minus 2. So certainly we get 2 pi I divided by e square. Now again integral of e power 2z divided by z plus 1 whole square dz is integral of e power 2z divided by z minus of minus 1 whole square dz is 2 pi I by 1 factorial derivative of minus 1. Derivative. So replace a by minus 1. That is we get 2 pi I by 1 factorial of derivative of minus 1 is 2 by e square. So we get 4 pi I divided by e square. So again the also integral of e power 2z divided by z minus 2 dz. This is directly we get 2 pi I f of 2 because a is 2, f of 2. This is 2 pi I, f of 2 is already calculated. Replace z by 2. What do you get? E power 4. E power 4. Therefore 2 pi I e to the power 4. So substituting all the values in the right hand side, we get integral of c e power 2z divided by z plus 1 whole square into z minus 2 dz is equal to minus 1 by 9, minus 1 by 9, 2 pi I by e square, minus 1 by 3, 4 pi I by e square, plus 1 by 9, 2 pi I e raised to 4. So we get a simplify. So 1 by 9 if we take outside, so 2 pi I we can take common. So 2 pi I by 9 of e to the power 4 minus 7 by e square we get. So we get one more problems. We come. So integral of dz divided by z square plus 4 whole square, where c such that mod z minus I equal to 2. Mod z minus I equal to 2, where c such that mod z minus I equal to 2. So we take a c such that mod z minus I equal to 2 is a circle with the center 0, 1 and the radius is 2. With the center 0, 1 and the radius is 2. We have 1 by z square plus 4 whole square is, instead of 4 I take also is plus sign is minus of minus 4 we can write. Minus of minus 4 we can write. So minus 4 can be written as 2i into 2i because I square is minus 1. So we instead of 4 we can write instead of z square plus 4 is there. Instead of z square plus 4 we can write z square minus of minus 4. So minus 4 can be written as 2i into 2i. So we get that 2i into 2i. So suddenly we can write 1 divided by z plus 2i whole square z minus 2i whole square. Let we take a is a point. A is a given one circle, a point with center is 0, 1 are say from a of 0, 1 be a center and the radius equal to 2 and the radius equal to 2. B radius is c. So I take a point P1 is equal to 0, 2 and P2 is 0, 2. So P1 take 0, minus 2 and P2 take a point 0, 2. So first take a P of AP1. So we apply the distance formula. Apply the distance formula AP1 here. 1 minus of minus 2, we get 3. Suddenly 3 greater than 2. This is outside the unit circle. Again, apply AP2. So 1 minus, so 2 minus 1. So 1. Suddenly 1 less than 2 is a lies within a circle, inside the circle. So hence 0 comma 2 or z equal to 2i only lies inside the C. So yeah, 2 comma 0 comma 2, that is 0 comma 2, that is z equal to 2i only lies inside the C. So that is, we can write this given problems. Now 1 by z square plus 4 whole square, we can write 1 divided by z plus 2i, z minus 2i whole square. That is, we can write in the form 1 by z plus 2i whole square divided by z minus 2i whole square. That is f of z divided by z minus 2i whole square. So taking f of z equal to 1 by z by 2i whole square. This is f of z. This is f of z. 1 by z plus 2i whole square. And a is 2i. We have first start to differentiate with respect to z. So f dash of z, we get minus 2 divided by z plus 2i whole cube. So differentiating with respect to z, we get, this is denominator square, denominator, derivative, numerator. We get, this is the term, we get derivative of f of z should be minus 2 divided by z plus 2i whole cube. So replace, so z by a, we get derivative of a should be 2 pi. What's the a value? Is 2i. So derivative of 2i should be equal to minus 2 divided by 4i whole cube. So replace a by 2i. So suddenly we get minus 2 divided by 4i whole cube. So I cube is minus I. So 4 cube is 48. So divisible by 2 divisible by, we get 1 divided by 2i. So here minus I minus n get cancels. We get 1 divided by 32i. So come to the Cauchy integral formula. So first derivative should be 1 by 2 pi I integral of c f of z divided z minus a whole square. The first derivative dz. So we get derivative f of a is get 1 by 32i. 1 by 32i is equal to 1 by 2 pi I integral of 1 by z plus 2i whole square divided by z minus 2i whole square dz. So substituting this value, we get integral of c 1 by z plus 2i whole square z minus 2i whole square dz is 2 pi I divided by 32i. So I get cancelled. 2 pi I divided by 32. Again 2 ones are pi by 16. So pi by 16. Thus integral of c dz by z square plus 4 whole square is equal to pi by 16. So we come to one more problem. Is very important. So I say evaluate integral of c sin pi z square plus cos pi z square divided by z minus 1 whole square z minus 2 dz, where c is such that mod z equal to 3. C in Z is a circle. C such that mod z equal to 3 is a circle with the center at 0 and radius equal to 3. With center at 0 and radius equal to 3, we come. So again we come to the proper fractions. 1 by z minus 1 whole square z minus 2. We can write a by z minus 1 plus b by z minus 1 whole square plus c by z minus 2. See, there observe here. Here a is 1, a is 1, a is 2. So all 1, 2 lies inside the circle because mod z equal to 3, where center is a and radius is 3. So this all lies within the circle, inside the circle. So we get again in the previous problem we can calculate a, b, c unknown by using the partial fractions. A partial fractions, we get a values of a is minus 1, values of b is minus 1, the values of c equal to plus 1. I'm substituting. So integral of 1 by z minus 1 whole square into z minus 2 dz is same as integral of a divided by z minus 1 dz plus integral of b divided by z minus 1 whole square dz plus integral of c divided by z minus 2 dz. So substituting the values of a, b, c, we get integral of minus 1. So say take minus 1 outside, minus of integral of 1 by z minus 1 dz minus integral of 1 by z minus 1 whole square dz plus integral of dz by z minus 2. So again I am substituting in the come to the problems here, that is integral of c sin pi z square plus cos pi z square divided by z minus 1 whole square z minus 2 dz is minus, so sin pi z square plus cos pi z square divided by z minus 1 dz minus integral of c sin pi z square plus cos pi z square divided by z minus 1 whole square plus integral of c sin pi z square plus cos pi z square z minus 2 dz. First, you evaluate side A. So what is Z here? First form Z equal to A. A is 1. Again, the second term A equal to 2. So Z equal to 2. So this suddenly lies inside a circle mod Z equal to 3. Again, f of z is given. F of z is sin pi z square plus cos pi z square. Derivative of f of z. Suddenly, derivative of sin is cos pi z square. Again, derivative of pi z square is 2 pi z. Again, derivative cos pi z square is minus sin pi z square. Derivative pi z square is 2 pi z. Again, if we replace z by 1, derivative of f of 1 is 2 pi cos pi minus 2 sin pi, 2 pi sin pi. Sin pi is 0. Suddenly 2 pi cos pi is minus 1. So suddenly we get minus 2 pi. If we come to the f of 1, so here replace z is 1. So f of 1 is sin pi plus cos pi. So sin pi is 0. Cos pi is minus 1. So f of 2 is, so sin 4 pi plus cos 4 pi. Sin pi 4 pi is 0. Cos 4 pi is 1. So I come to this, directly come to the problems. Integral of c sin pi z square plus cos pi z square divided by z minus 1 dz is 2 pi I f of 1. What's f of 1 is minus 1. Therefore 2 pi I minus 1 equal to minus 2 pi I. So again come to second term. Integral of c sin pi z square plus cos pi z square divided by z minus 1 whole square dz is 2 pi I by 1 factorial, because second here 1 factorial f of 1. F of 1 already minus 1. So 2 pi I minus 2 pi I. So 2 pi I of minus 2 pi. So we get 4 pi square I. So again, if we come to the integral of c sin pi z square plus cos pi z square divided by z minus 2 dz is 2 pi I f of 2. What's f of 2 is calculated is 1. So 2 pi I into 1 is 2 pi. So substituting in the given equation 1, so integral of c sin pi z square plus cos pi z square divided by z minus 1 square into z minus 2 dz is minus of minus 2 pi I minus of minus 4 pi square I plus 2 pi I. So totally simplify, we get 4 pi I plus 4 pi square I. So if we take 4 pi I as a common, we get 4 pi I of 1 plus I. This is the simple formula by using Cauchy integral formulas.